Hello and welcome. Your knowledge about the transform position and rotation of game objects and your understanding of how to move and rotate game objects is fundamental in Unity game development. To move or rotate a game object is to change the transform position or rotation of the game object respectively. In the scene view, you can use the move and rotate tools to move and rotate game objects in your scene, or you can enter those values in the inspector window directly. In this tutorial, we'll be looking at how to move or rotate game objects using C# scripting. To begin with, let's consider what vector3 is. Vector3 is a data structure that stores the x, y, and z values of the position of a game object in space. The following are some familiar properties of vector3. Let me briefly demonstrate how these values can affect the position of the cube in the scene. Pay attention to how the different functions in the script are linked to the on-click events of the buttons. As we click on these buttons, read the messages in the console window. When a button is clicked, the cube changes position within a single frame. This is too quick. We want the cube to move smoothly from its original position to the new one over a period of time. We can take advantage of the update function, which runs once per frame, to accomplish this. This code in the script will keep moving the cube to the right, but smoothly. This code in the script will keep moving the cube right at the same time forward, thus producing a diagonal movement. Take notice that the lines of code can be rewritten this way. To accept input from the keyboard and move the cube accordingly, we need to take advantage of the input.getAxis function. The input.getAxis function allows you to map either the x-axis or the z-axis in your game with an input from a mouse, keyboard, or joystick. You can find the different input options by going to Input Manager under Project Settings. By default in Unity, the x-axis is called horizontal and it is mapped to the left and right arrows. Then the z-axis is called vertical, which is mapped to the up and down arrow keys. The value returned by input.getAxis when a keyboard is pressed is in the range of -1 and 1. Now let's get back to our scripts. Anytime the update function runs, values for the two axes are captured based on which arrow keys are pressed. The values of the two axes will represent the x and z values of the vector position of the cube. The y value will remain 0. We will set the transform position of the cube to this vector. For a slower and more gentle motion, multiply the change vector by a speed constant and also by time.delta time. Another way of doing this is to use the translate function of the transform component. The rotation of game objects can also be changed. The transform.rotate function is used for that. In this script, the first parameter in the rotate function stands for the axis around which the rotation will be made. The second parameter is the angle of rotation. So this cube will rotate around the y-axis by 1 degree per frame. The angle of rotation will determine how fast the cube rotates. An interactive approach is to rotate the cube based on input from the keyboard. Here, we want to rotate around the y-axis again, but this time using the left and right arrow keys on the keyboard. So far, the camera remains still when the cube moves around. To rotate the camera to also look at the cube, we use the transform.lookat function. Watch how this is done in scripts. A transform variable first references the transform component of the main camera. The last line rotates the transform of the main camera to point at the cube. The second parameter specifies the upright direction of the camera. Change it to vector3.down and see what happens. What if we want to move the cube to follow the position of the mouse on the screen? That is simple. Let me explain the code that does that. We first get the mouse position. See the vector values of the mouse as it moves on the screen. Notice that the z-axis value of the camera is always 0. Since we are going to use this vector for the transform position of the cube, we need to give the cube some depth so that it comes into focus. Hence, we must give it a value greater than 0. Now let's convert the mouse position, which is based on screen points, to world points. Finally, let's set the cube's position to that of the mouse. With a depth of 1, the cube appears very close. Let's position it further by changing the depth to 10. Remember to set the z value of the vector to be greater than 0. We can also use lookat function again to rotate the camera to always focus on the mouse position on screen. In conclusion, we have seen how to move and rotate game objects. Do well to practice this yourself and tweak the code and values to see the results. Please subscribe to this channel for more videos. Thank you.